welcome to a new composing visual music tutorial. This time I want to switch gears a little bit from what I have discussed so far, introduce some changes in the way I do audiovisuals. In particular, I decided to skip the OpenGL pipeline and start using pixel shaders. So first and foremost, the reason why I decided to go to pixel shaders to do visuals is that it relies entirely on the GPU. What that means is that my CPU is left free to do any audio processing, and that is a substantial advantage because we are keeping the two processes separated. But also there are some aesthetic differences between using OpenGL polygons drawing to use a pixel shader. The way that shapes are rendered in a 3D context when I'm using fragment shaders relies entirely on volumes, which means that I can really generate more plastic looking sort of shapes. So there is a lot of source code that I can tap into when I do pixel shaders, and the most important one would be the Shadertoy source. And there are thousands upon thousands of shaders that I can look at, and the code of which is readily available for everybody to see. You can really compact all of your visual stuff into one JIT object, which is JIT slab, and have just a text editor open and do all of your visual work in that text file. The disadvantages, there are not a lot of built-in functions for GLSL. I don't have objects like a grid shape that gives me a readily available primitive, and I need to build a lot of the functions from scratch. But again, I can refer back to Shadertoy for a lot of help. The 3D rendering can be a little bit tricky because it's done with this technique that's called ray marching. And I need to have a function that just implements that in order to visualize things in 3D. Texturing can be a bit tricky. It's not as easy as having a grid shape and applying a texture to it. Physics, I've never done it, but I assume it's not that easy. So as I mentioned, it's no longer possible to use grid shapes and meshes and GGL NURBs. We can still use textures and things like GGL BFG. We can feed them into the GGL slab. I can pass in audio or MIDI information using textures. So that's a very cool feature of using Max and pixel shaders. If you have experiencing trouble with complex audio patches that clog up the CPU and make the rendering of visuals complicated, then this is definitely something to look at. And if your computer has a good GPU, graphic card, then for sure that's something that can be helpful. I wouldn't suggest doing this if you don't need to, meaning you already have whatever you need in a normal Max plus jitter patch. If you don't have Max 8, that would be a problem because you need the GL3 package. I listed here 2 YouTube channels that are helpful to learn. I really say helped me a lot. And most of all, Shadertoy is a great resource. So let's start looking at Shadertoy and what the main window looks like. So this is the window when I create a new Shadertoy. So this is my only function as a default. and I have one input, which is the frag coord, which is like the cell object in the GGL pix. So it gives me the coordinate of each of the pixels, and the output is the frag color, which is a vec4. So the first thing that we need to do whenever we start doing a shader is to normalize either 0 to 1 or -1 to 1 value. So that would be correspondent to create a norm or a S-norm object. So normalized coordinates or signed normalized coordinates in GGL pix. So if I divide the coordinate by the maximum values of the x and y, I will have values from 0 to 1, meaning the pixel in the left corner, in the lower left corner is 0, 0, and I will get rising values going up to maximum high resolution value into the upper right corner. So this is already a normalized sort of coordinate. If I want to have the sign normalized coordinate, I need to multiply this by 2 and then subtract 1. So I can try to visualize these coordinates by just replacing the vec3 that forms the color with my UVs. So I need to create a vec3 again. So variable are created using a certain type, and in this case the type is vec3, which is a vector of 3 values, three-dimensional vector, and then I can use the UV x, which will be the x coordinate, and then a UV y, which will be my pixel coordinate for the y dimension, and then give a 0 for the blue channel. For positive values, I have the green, the red and green channel being mapped by the x and y coordinate, and these are all values that are less than 0, and that's one thing that is important to know, that values that are less than 0 are rendered as black. So if I take out if I instead want to map the normalized coordinates instead of the sign normalized coordinates, I can take that part out, and in this case I will have a value 0 here, and then the x and y reaching 1 at the upper right corner. Okay, so let's start with an easy task, which is to draw a dot into this space. We'll keep the color as it is, and to create a dot, what we can do is to have a position. So right now we are working with 2D coordinates. So I can create a position of vec2, call it pos, and just create a random position. Say 0.1 and minus 0.2, and this is my position. I can use a length of the pos minus the UV, and this will give me the distance from the pixel that it's passing through, and the position that I created. And then I can so this will be the length is a scalar, so it's a single value. It's not a vector. So I can say, I can call this dot. Cannot use the word dot because it's reserved for other things. So if I render that, I will have the distance between my position that I've created here and the position of the pixel itself. If I invert this, so I get this. So I can use a step function to draw this as a discrete dot instead of having like a larger shape like this. And to do that, I can use the step function, which is similar to the smooth step function, but it takes the smooth part out. So it's the output, it's either 0 or 1. And when the switch happens between 0 and 1 is determined by the first argument of my step function. Whenever the distance is less than 0.1, I will have 0. And whenever the distance is more than 0.1, it will be 1. So if I want to have a white dot instead of a black dot, I can just do 1 minus as a step function. And so we can go ahead and load a texture, for instance, load a texture and get just some noise for the time being. Let's get a color texture. This is 4 channels and it's 64 by 64. These are important informations. Have this position, instead of having to hardcode that position in, be decided by my texture. The function textile fetch, which is pretty much like using nearest pix or a sample pix. First input, I have to give it I channel 0, which is where the buffer where my texture is stored. And then I have to give it some coordinates. And the coordinates need to be a vector of 2, and in particular an integer vector. Let's just extract the first, and I don't need the dot there, the first cell. So the bottom left cell, which is 0, 0. And the textile fetch requires a third value that we can just set to 0. We don't need to worry about that now. And then in this case now I will have a texture, a value of 4 channels that comes out of here. Because as I've seen when I loaded the texture, that the texture has 4 channels. So I can only extract the X and Y channels because that's what I need to do for my dot to be drawn. So now if I compile by hitting Alt and Enter, then my dot is drawn somewhere else. If I want to draw many of these dots, then I can use a loop. So let's use a for loop. And I have to give the variable type for the looping variable. So if I equals 0, I minus a certain less than a certain value, which can be like 20, for instance, and I plus plus, instead of using fixed values, I can just use the loop variable. And in this case, I need to accumulate the call value as I go through the loop, because otherwise only the last one will be drawn. So what I can do is just simply create a call variable at the beginning, just leave it at 0, its default value. Call plus equal vec3 dt. So I can create a function that that takes the UV as inputs and the position, and returns a float that is my dot. So here I can just add dt equals the dt, my function, with the UV and my pos. So I can see how these are not perfect circles. So I can actually just do multiplied and then equal to this to adjust the ratio based on the Windows coordinates. So that's the first step into using fragment shaders in Max. Next time I will bring it into Max proper and start doing some experiments with textures. If you are interested in seeing where this goes, stick around. Remember to subscribe and leave comments and suggestions, and we'll see you next time.